Hello and welcome to this third TextFabric tutorial. In this one we are going to have a look at some very basic data mining operations. We will use pandas in order to search our data and organize our data, filter our data and so on. And we will also do some very basic plotting, so that is visualization of the data that we generated. So let's get started. In this notebook we will be loading our TextFabric queries, the ones that we have exported in our last tutorial. Then we are going to do some very basic data mining operations, and finally we visualize some of our data results. So the first thing that we have to do is we have to load some Python libraries that allow us to do data mining and visualization. Basically what this is it says import from a whole collection of libraries the pandas library as PD. So it's basically an abbreviation, PD. It allows us to write a little bit faster. We don't have to write out pandas all the time. PD is enough. So PD stands for pandas, and the same is happening here in these other lines. So let's run this command. Here we go. We're loading all these libraries. Should be fairly fast. In our next step, we're going to import our TextFabric query results that we generated in our last tutorial. So what this does is it says let pandas, PD, pandas, let pandas read the following CSV file, the following spreadsheet file, and here I give the entire location. Delimiter means it's a tab separated file, and then I also have some encoding UTF-16. That's so that we can see our Hebrew fonts well. Okay, then I also say pandas to allow me to see up to 50 columns. Sometimes there are many columns and I want to see them all. It's not really necessary with the little files that we have generated in our last tutorial, but it's handy to be aware of this option, particularly if your data has many columns and only perhaps 10 are shown by default. You're not able to see all of them, so here you can manipulate the number of columns you want to actually see on your screen. And then we want to see our data frame. That's our spreadsheet. It's called data frame in pandas. So we just call it BHS Abraham search. This is the name for our data frame, BHS Abraham search. And then we just want to see the head, the top 5 lines of our spreadsheet. So when we run this command, we will see our actual spreadsheet. In the next line we do the same, but we now import our New Testament search that we have exported. So now we have the New Testament, and well, I did some on iTheos. Let's import this as well. Okay, so now all the data frames are imported. We can now do data mining, which is the next step, some simple data mining operations. So you need to imagine pandas and the tools that we're using here as very powerful Excel type of operations that we can run, but we can run them on massive amounts of data, such big amounts of data that Excel would have difficulties to work with. Okay, good. So here just a couple of examples. You see we're using the group by option, the sum option, the count option, sorting values, finding values. This is what we're going to do in the next line. So imagine you want to group your BHS Abraham search data by the lexeme. You see we have here the lexeme, lex1 in transliteration, Abram, but we know there are also other lexemes, namely Abraham. So why not just group them according to their lexemes? So this is what this command does. It says use this data frame and within that data frame group all the data by column lex1, and then give me also the sum of each column. So if we run this command, you see now we are grouping all the data according to the lexeme, lex1, Abraham and Abram, and we see we find 25,742 times Abraham appear in our data frame and 2,224 times Abram appear. You might think, well, it cannot be that the Old Testament has 2,224 cases of Abram. Well, that has to do with the fact that we're using sum, because what sum does, it basically it sums up all the numbers that appear in the R column, 1 plus 2 plus 3 plus 4 plus 5 and so on. S2, 11 plus 11 plus 11, so 33, 44, 55. That's the reason why we get these high numbers. So that they're not really meaningful at this moment for us, but the sum function will be quite helpful at a later stage. Now, when we do count basically says how often does Abraham appear? How often does Abram appear? That's what count does. So when you run the count command, it shows you Abraham appears 175 times in the Old Testament. You see each column lists the same number. That's because each line has Abraham appears in each line, and so each line is counted as one line. So 175 lines have Abraham appear, and then 61 times Abram. So these are just simple group by functions with additional counting options or summing options. Now we can say group by lex1, count, and then do a summary, then a sum. And here are our results. So if you look at this, it's basically this plus this 236. This plus this 236. Okay, here we go to the New Testament search. So we're going to the data frame NT Abraham search lex. So that's a different one than the one that we had here. So NT Abraham search lex, that's this data frame that we created. Okay, so let's play with this. We do again a group by S1. S1 stands for Bible book. We can change these names at a later stage. We'll learn that in another tutorial. And then we count. So how often is Abraham appearing in each of the New Testament books? You have it. Most of the time it appears in the book of Luke. Now we can also say group by book, then do a count, and then we want to sort the values from the biggest to the smallest. You see here we had no order in the numbering. There was an alphabetic order, so you first said number 1, number 2, and then A, B, C, D, and so on. But perhaps we want to order our data according to the distribution of the Abraham findings. So this is what we do. We say group everything according to the book, this one. Then do a count. Yes, that's exactly the same command that we had here so far. But now in addition, we want to sort our values as they appear in text 1. So, and we want to have them in ascending mode. You see, we're going now from 15 down to 1. So let's run this command. Here we have it from 15 down to 1. We could also say ascending is true, Now we should go from 1 up to 15. Here you see it, 1 up to 15. Okay, good. Now we can find values, of course. So in this case, we are saying in this data frame, please filter out of this data frame all cases where the lex1 column, here that's the lex1 column, has the value abram only. Yeah. So when you run this command, you see that we find all the cases in Genesis, 59 cases, where Abram appears. From Genesis 17 on, there's no Abram anymore. And then we find one case in Nehemiah and one case in First Chronicles where also Abram appears. It's the appearing in the genealogy. So the double equal sign tells you we want to find all cases that are identical and only identical to Abram. We could also do the negation of it. Negation in Pandas works with exclamation mark, equal sign. So what we are doing here is basically just a reversal of this. We're saying we want to find all cases in which lex1 does not have Abram. Does not have Abram. So when we run this, you see now we only have the Abraham cases. Abram does not exist. You see our Nehemiah case will not appear. Okay, we can also combine values in different columns. So in this case, we're saying within the BHS Abram search data frame, we want to find of that data frame in column lex1 Abram, the Abram value, only this value is allowed. And here we have the sign. We want to pair this with, we want to have a match where the Abram value appears together with the Genesis value in the S1 column, which is the Bible book column. So when we run this, we'll see, I said not in Genesis. You see here my exclamation mark equalizing. So it says I want to find all cases where Abram appears in the lex1 column and where the book column does not say Genesis. And here we have our two cases. In Nehemiah 9 verse 7 and 1 Chronicles 1 verse 27, Abram appears. These are the only two cases where Abram appears outside of the book of Genesis. And well, these are now further placed with the same type of rationale here. But I want to make you aware that you can also use the greater, smaller than signs, particularly when it comes into numbers. So in this case, we're searching for all Abram entries in the column lex1, paired with all cases where the value appearing in R is bigger than 59. So R stood for, that's just the listing of the cases, so that's not really a meaningful value. But you could say where all, for example, chapters, it would be S2, where all chapters must have a higher number than, for example, 20. And now you find, well, obviously there is no Abram appearing anywhere in the Bible in a chapter that's bigger than 20. We know that Genesis only has them till chapter 17. So let's do this. Bigger than 10. That should give us some Genesis. Yeah, here we have our Genesis cases. Okay, good. Let's go back here to 50 and put this back here. Okay, then in this case, we are searching 4, you see 3 value pairs. So we want Abram in the book of Genesis. Now it's equalizing. So only Abram in the book of Genesis. And it must be in a chapter that is higher or having a number higher than 17. Well, we know in Genesis Abram does not appear. So we should have 0 cases. And there we go, 0 cases. Of course, as we go down now, in chapter 17, we know that we have Abram appear. So if we say we want to find Abram only in the book of Genesis, only in chapters that are bigger than 16, here we have our Genesis 17 cases. Okay, good. So you can now run these combinations and they help you to really dig into your data and find patterns. Good. Let's now get to our final part of this tutorial, namely data visualization. When you work with a lot of data, it's often difficult to grasp and understand what you actually have, what you actually found, how that phenomenon is distributed. So in this case, plotting and data visualization is really helpful. So I have here 4 options: simple bar plotting, scatter plotting, imploding, and pie plotting. What these different commands do is they use different Python functions and Python libraries to generate these visualizations. So in this case, we're using the powerful PLT, that is plotting, the plotting library of Python. And one can define the size of the figure, the DPI, the face color, and so on, edge color. And then you see, let's run this command so that you can see how you can manipulate this. You could also say I want 10 here, and now you see how this has automatically changed the size of the actual plot. Let's do it the other way. And now it has changed. Yeah, so you can play with these numbers. You can increase your DPI, pixel density, particularly when you do want to export these files into perhaps a printing environment. And you need, of course, high DPI. Usually for printing, they require 300. So you see now we have a 300 DPI version. Then you can change the face color. The abbreviations that you can use, W is for white, B stands for blue. There are many different versions that you can use. Edge color, we can change that into something different. So you can Google this and then see what colors you have available. There's basically endless colors because you can also use CM, RGB, and CMYK. Good. So the first line is just about how you want to display your graph. The second one tells what to plot. It says, please plot the following data out of the data frame BHS Abram search. Please group the data according to Bible book, as one is a Bible book. Then measure the size of the appearance and then sort the size in an ascending way and then plot it as a bar. That's what it does. These ones, the following 4 lines, they just allow you to add labels. Label on the x-axis, on the y-axis, a title, and then you of course want to show. You don't need this. We can just delete this, and it will still run, but you see now we don't have a title and we don't have y and x-axis being there are no titles, there are no descriptions for the y and x axis. Okay, so that's what the plotting does. Now we do the same with the New Testament. You see, I'm searching now for different data frame. It's the NT-Abraham search lex. We group it again, then we want to have a size, we want to sort the values, and then we want to have it plotted. Here we go. So Abraham appears most often in Luke, then in John, in Hebrews, Romans, and so on. And a plotter mechanism that is very, very helpful, at least I found that again in my research, is to have scatter plots or implots. They're really powerful. They are a little bit more complicated to understand, but you can just copy paste them into your own cell and then change the data frame that you're working with. So make sure you put the right name for the data frame in here, and then also adapt here the values. And now you have a nice scatter plot. I'm running now on the data frame PHS Abraham search. Grouping of the lexemes. We have two, Abram and Abraham. So, and then it plots it out. You see everywhere where we have Abram, we have what is that, orange, and Abram is blue, and it shows us in which book these lexemes appear. Obviously, it's just in Genesis, in Nehemiah, and Chronicles. We can also do some implotting, which is more powerful because it shows you also how the values are distributed. So in the simple plot, we just see in the simple scatter plot, we just see that we have a presence of Abram in the book of Genesis and a presence of Abram in the book of Genesis, but that's it. It doesn't tell us anything about how often and how frequent. This is very different here in the implotting. It allows us to see that there is a much higher frequency of Abraham appearing in the book of Genesis than Abram. It shows us also how frequent the words appear in other books, and here you see the little blue and orange colors here over Nehemiah and First Chronicle. That's what we saw here, Genesis, Nehemiah, and First Chronicles. Good. Let's run the same implot on our New Testament data with Abraham. So what it does now is we made it sensitive to the way how Abraham is written. So there are several different ways the accents are written differently. And so it shows us which word appears in which book in what type of frequency. So that's a nice way to analyze your data and understand your data better. So we could change text 1 into our lexeme. So let's see whether we have what columns we exported into our data frame. Text 1, okay, good. It just has text 1 for the Greek fonts. We didn't export the lemmas, so therefore there we could type in here unlex, for example, or some other values that we could then scatter. Okay, then we have this example of Ortheos, the data that I was searching for in the last tutorial. You see that again the different writings and the distribution. Mark obviously uses Orthos most of the time, more than any other book, and in a particular type of writing, the accents are distributed in a way that only Mark does. So that's something interesting that would also invite for further research. And then we have simple pie plotting. This is again a plotting, but now not as a bar, but as a pie. And yeah, this generates this type of graph, pie. Here we go. All right, I hope that was helpful. What we are going to do in our next tutorial is we're going to build a vocab list for Hebrew and Greek courses that you might want to teach in the future. For that we need to run a TextFabric query, and we need to do some data mining, and from there we can build a nice booklet for Hebrew and Greek vocab. Probably in about a week or so we will then dig into a little bit more of the data itself that's available, particularly in the Hebrew text, and equipping us to get into some more depth when it comes to research questions and research operations. All right, that's it for now. See you next time.